And welcome to day 11th of January Leetcode challenge, and today's question is merge two sorted arrays. In this question you are given two sorted arrays, array 1 and array 2, nums1 and nums2. You need to merge these two arrays without using an extra space. Also it is given in this question that the first array has an extra space at the end and all the element equal to the length of nums2, and all the elements in nums1 can be accommodated. All the elements in the nums2 can be accommodated in that of nums1. So you need to generate the sorted array that is a combination of first array and the second array in the nums1 array itself without using even a single extra space. It seems like a tricky question because of the extra space constraints. Otherwise you could have applied any sorting technique and you could have done it. Let's talk about the algorithm, which will require no extra space, and let me just start. In the solution we'll be using three pointers. One that will be pointing to the end of the first the second array, one that will be point to the end of the second array, and another one that will point to the actual length up to which the first array is set, since these are just for occupying the new elements from the p2 from the n2 array. So we'll have three pointers set. One is the terminal of the tail of the second array, one is the actual terminal of the first array, and one is the terminal up to which from which the number actually starts in the first array. So what we are going to do, we will move in the backwards direction. Out of p1 and p2, we will pick up the maximum one. We'll choose the maximum one. Sorry, it's written incorrect. We'll pick up the maximum one, and we will set it at e1. So we will set this at e1, and we will reduce the selected pointer. So in this case p2 gets selected, so p2 points here, and e1 also gets reduced because this has been occupied by the maximum element in the array. So whatever out of the two contenders, we'll pick up the maximum one, and we will then reduce the even counter and the selected pointer position. So e1 now points to this position and p2 points to this position. Let's talk about what are the two contenders now. The two contenders are this and 3. Which one is the maximum one? 5 is the maximum one. Again you will set 5 at e2 e1. So 5 gets here, and p2 reduces. p2 points to this position, and e1 reduces as well. So even points to this position. Now out of the two contenders 2 and 3, which one is the maximum one? 3 is the maximum one. So 3 gets set here, and p1 reduces since you have chosen p1 this time, and e1 reduces because it has been filled. So e1 points to this position now. So this is e1, and out of p1 and p2 both have the same value. You can choose any one of them. So let's assume that I have chosen p2. So p2 gets picked, and this position gets updated by 2, and p2 reduces to -1. The loop exits, and now we have the sorted array 1 2, which is 1 2 2 3 5 6. We have done it in place without using any extra space. The only critical part to think in the interview is you have to choose the maximum element, and you need to go in the direction starting from the backwards one, starting from right to left, because we are sure which one of the two possibilities would be the maximum value. Let's quickly code this up in exactly same manner what I have stated. Let's initialize the two pointers. Integer p1 equals to m minus 1, integer p2 equals to n minus 2, integer e1 equals to nums1 dot length minus 1, because eventually we need to store all the elements in the first array. So while e1 is greater than or equal to 0, what we'll do, we'll extract the two contenders for the maximum value. Integer first element equals to, let's check whether p1 is greater than or equal to 0. If it is, then let's return that value nums1 dot p1. Otherwise let's return the minimum integer dot minimum value. Similarly, let's do it for the second array. and this is the second element means second container. If first EL is greater than second EL, that means first element gets the position. Uh, then we will set it in nums1 EL1 equals to first EL, and we will reduce P1 minus minus E1 minus minus. Otherwise, we will choose the second element P2 of E2 E1, nums1 of E1 equals to second element, and just reduce P2 minus minus E1 minus minus. That's it, and we are out of the loop. Or you need to we don't need to return anything, and we are. And it passed. Let's talk about the time complexity of the approach. Time complexity is order of m plus n, number of elements in the first array and the second array, and the space complexity would be equal to a constant space because we are not using anything extra for this. Order of 1. Thanks for watching the video. Hope you enjoyed it.